Today we're going to talk about logarithmic equations and graphs. So logarithm are just ways to solve for or isolate an exponent. So if your x is in the exponent, this is how we can get it out. It's also the inverse of an exponential. So they're opposites of each other. Logarithms are in the form log base a of x. If there is not a base, we know, like if it just says log 10, that means that it is a base of 10. There's an imaginary 10 there. So we know square roots are imaginary 2s for the indexes. If there's no number in front of x, it's an imaginary 1. If there's no base with a log, it's an imaginary 10. We're going to write the following logarithmic form. So we're going to kind of do the inverse of it. If I see 2 cubed equals 8, 2 here is a base. We know that. So we're going to write it as log base 2. So it's log with a little 2 underneath, like a subscript. And then our answer is going to go next to that because we're doing the inverse, equals the exponent. So our base goes down below, our answer goes next to the log, and then it equals the exponent. We're trying to solve for or isolate the exponent. For 2, we have 5 squared equals 25. So again, that 5 is the base. We're going to have log base 5. We put our answer next. 25 equals our exponent. If you type that into Desmos, you would find that log base 25 is 2. So that's a great way to check. And I will show you how to check it in Desmos in a little while when we do the graphing, how to type that log base in. And for 3, we have 1/3 squared equals 1/9. So we can do log base 1/3 of 1/9 equals 2. So again, it's log, our base, the answer, and then the exponent. So if we're going in opposite directions, we know they're inverse of each other. So we can go from exponential to log. We can also go from log to exponential. So for 4, we have log base 4 of 16 equals 2. So we said log base 4, so 4 is my base. The thing on this side is my exponent, and then that's my answer. And we can check it. It should make sense. We know 4 squared is 16. If I have log base 3 of 27 equals 3, my base, I write that first. My answer is now going to become my exponent, and then this thing next to my log is my answer, or what I equal. This one here is a little tricky. There is no base written, so we know it's an imaginary 10. So we're going to have 10, that's my exponent, squared, equals, that's the answer, 100. So we're going to find inverses of the following functions. Remember, when we find the inverse, we're going to switch x and y. There isn't a y here, so we know f of x is really a fancy name for y. So I like to write that first. So that's my original problem. And then I know I need to switch it because I'm finding the inverse. And then I need to solve for y. So I need y out of the exponent. So I have x equals 3 to the power of y. Inverse of exponential is logarithmic. So I'm going to write log. My base is 3. My answer was x, and my exponent is y. So I know that my inverse function, I have y by itself now, is log base 3 of x. And we'll check it in just a second.